And let me introduce, it's Sir Wombat and Nero Lapis Lucis. So give them a warm welcome when everybody's interested in how to get the stuff done.
We're going to present our juice press, which is this gorgeous instrument you can see over there. Then we will talk about the fermentation vessel you will need if you want to build one yourself. And we will explain shortly again how you can create alcohol out of the yeast and the fruit juice. And afterwards we will present the model of a still, which you can see over there on the desk.
Yeah, by model we mean it doesn't actually work.
Yeah.
It only looks like it.
Yeah. So it's a kind of a hypothetical operations of a miniature still. And yeah, afterwards you will get to know an alternative method of kind of getting high % alcohol, which is the ice rifting. Yeah. This is that. So who are we? I'm Nero. I'm kind of a professional Viking. So why am I presenting this talk? I was studying abroad in Norway and I was too broke to buy the beer. So I had to find some solutions and I started making the wine. So Wombat over there is an electrical engineer and he's just building stuff since forever. Yeah, let's start with the juice press. I don't know, do we have the camera or are we doing it without?
Yeah, yes, I can just hold it up and maybe you see it.
Yeah, so basically what we have is you have the wooden frame and then there's a car jack attached to it. And with that we press this kind of wooden block down. And then we have on the right hand side, it's like this wood part which has this special shape so the juice can run off. This is on the lower side. And there's the fruit between it. And with the car jack you get lots of pressure. Actually you can also, if you boil the mash, you can just use the kitchen towel. But it's a lot of work. So this is actually kind of nice. Yeah, you can do it with whole apples. You can cut them beforehand. You can put them in the oven for a little while and it makes it actually a lot easier. So I don't know. I think it's easier if you kind of boil them or put them in the oven beforehand and cut them. Then you get a little bit more juice. Because what you see when you try this is that you have a lot of work and a lot of fruit for actually very little juice. It's yeah, it's a lot of work. Yeah, I mean the thing is the fruit juice, what is useful for the alcohol, it's basically just the sugar water. So you can cheat, which is actually not allowed, but in theory you might cheat and add sugar to your fruit juice and then the yeast has more kind of fruits and more basics to produce the alcohol from. So you can add molasses to the fruit juice and by that increase the alcohol outcome of your molasses. Yeah, so this is in basics the process we just heard about. You have the sugar water and the yeast is working in the sugar water, and by that creating alcohol and CO2. That's why you need the fermentation vessel, which we will talk about in the next part. You can basically just use normal yeast from the supermarket. You could also use some yeast cultures which are on the fruits. There are some kind of hippie wine producers which just use the apples like they are and use the cultures which already are on them. But it's better to use the specialized yeast because you have optimal alcohol outcome and lower risk that there are other bacteria evolving, kind of. What you don't want is that there's oxygen coming into your fermentation process, because then what you get isn't alcohol but vinegar, which is kind of tastes disgusting and it's not what you make it for. So that's why we are building the fermentation vessel. It's basically just a mechanism to keep the air away. Yeah, this is kind of ingredients, what you need to do for it. On the left-hand side, this is, was my first experiment. On the right-hand side, it's Sir Wombats. So he has this special thing that he puts a pen in the kind of peanut butter jar beforehand, so the hose will stick better. You don't really need to do that if your hose is kind of thick enough. So I had this gasoline hose and it worked just kind of fine. So you have to fix the hose in your fermentation vessel and in this kind of jar which is filled with water. And this you can just use glue for that, but it needs to be airproof. And what's happening is the CO2 which comes from the fermentation process is can leave the vessel through the hose. And so it just goes into the glass of water. And the water, the effect is just that no oxygen can come in and go the other way around. So it's really simple. It's useful to have a fermentation starter. So for that, you start with activating the dried yeast. And the thing with that is that you give the yeast, which you want to kind of have a good life in there, a head start ahead of all other bacteria or kinds of microbes which would want to evolve in there. So yeah, it's not that important that you keep the air out because you don't keep it for that long. So what you do is just you take the yeast you want, you put sugar in there, and you put the molasses in there. And you just give it a head start with a lot of sugar and you keep it in there for kind of, yeah, about 12 hours. And then you keep it, then you put it in the fermentation vessel and you add the rest of the molasses. So it's not really in there for that long, and because of that, it's not that important to keep the air out. It doesn't have that much contact. So here you can see the fermentation process. This is kind of which was yeah, it's kind of a peanut butter jar. And there's the air coming out, the CO2. And it looks like that. When the fermentation is running on high, it can get a lot faster. But during most of the time, it's also this nice blubbing sound. If you keep it in your room, you will have it at night. So how will you know when your fermentation ends? Some of the yeast will die. You will notice this at the bottom of the fermentation vessel. It will just float down. And you also will notice that the fermentation process is getting a lot slower. So why does this happen? Either you have already too much alcohol for the yeast to survive. This depends a bit on the kind of yeast you're using, but mostly it's about 15% you can get. Or maybe there's just no sugar left. You don't really want that to happen because then it doesn't really taste that good. But basically it's also a possibility if you just want the alcohol. Just remember that you shouldn't bottle it before it's totally finished because as long as there's still some fermentation going on, there's also CO2 coming out and your bottle might explode. You don't want that. But if you continue with distilling the whole thing, it doesn't really matter because you work with it and you don't bottle it. So what do we do now? We have like the finished wine in the fermentation vessel and you have the dead yeast on the ground. So you should be careful when you fill it in bottles or fill it in another vessel because the dead yeast tastes kind of nasty. So you should siphon it off, or you can also pour it, but then you should take a lot of time and be very careful with it. Yes, to measure the alcohol content, which will be, as I explained earlier, about 15% in the mesh. There's different tools. So for the mesh, we have the vinometer. And if you want to measure it in the still output, you have the hydrometer. And this is when I give over to my friend. Yeah, sugar is a problem in measuring actually because it kind of confuses the instrument, both of them. So you should consider this. And actually, it's not really that fancy, so you can get both of them for like 10 euros. It's useful to have. Yes, we had that already. The results you get with the fruit wine is normally between 6% and 13%. 13 is already kind of high, so if you just use the process like I explained it, it's, probably a bit less. So that's actually why you would want to still it afterwards.
Yeah, so Now we're talking what would happen if you'd want to build a still, and we're not talking about an actual still. We're talking about a model that looks like it could work, but doesn't, because, as we said, we wouldn't break any rules, and Stefan said it's not allowed, it's not legal to do so. So, yeah, the thing to build such a model, such a home-sized model, not a semi-professional one, you don't need all the, like 5,000 euro was the cheapest professional one we talked about. So yeah, for such a tiny model, you could get away with 75 euro if you're really resourceful, like using an old pressure cooker from a GDR. Those are, funnily, the cheapest ones you find on eBay. This size is like 10 euros, so it's a nice thing. Yeah, some copper pipes you can get in your hardware store. That type of copper pipe is used to connect fridges. Like for that fresh water and ice cube feature fridges have. Yeah, the cooling system is just an old canister, and yeah, some electronics I'll talk about later. So yeah, let's just get back to the slides. Back to the slides, please. Thanks. Yeah, the temperature sensing command we'll talk later about, and then that's it. So yeah, you just connect the copper pipes like this in a T-form with a cork on top, and the screw thing on the bottom to connect it to the lid of the pressure cooker. Yeah, that's the point. You use like an end cap for the copper pipe, drill a hole into it, and connect the thinner copper pipe to it. That will go onto the pressure cooker like this. Then you need to do some soldering. Most of you probably know how to solder. This is another kind of soldering. Yeah, it's the same thing. You use tin, you use copper, and some flux to make it flow easier. And yeah, not a soldering iron, but a blowtorch, but that's all the difference there is. And then you just drill a hole into your cut open canister, push it on there, and use lots of glue to make it waterproof. It's no rocket science. Yeah, then the temperature measurement. We want to have that because in theory you need a very precise measurement. In practice, it didn't seem like we couldn't live without it, but it's very interesting and it's helpful. How do we do that? Just use one of those cheap integrated digital temperature sensors, a Raspberry Pi, a real-time clock to date the measurement protocols. That's just nice to have. Yeah, a bit of Python script that's, yeah, mine's ugly, so it's not published, but everybody can do it. It's like a day of work. That will output a small website that shows the current temperature graph. Yeah, you can click on this link and download the current temperature, like all the measurements as an Excel file, and you can even download former measurements. That's why we need a real-time clock, so that we don't start a chaos. Yeah, that's all there is. If you have Wi-Fi, it's nice because you can leave the room while it's running, but yeah, then you see something is not going well and then you rush back, so you probably stay with it anyway. Yeah, now this is how a hypothetical run-through would look like. A tablet in the background showing the temperatures, the Wi-Fi router. Yeah, now, yeah. It's a really great guy that he yeah, puts up with this. So, yeah, you open the lid, you put in your mesh. remember this is only a model, then like if your pressure cooker has a broken locking mechanism, you use some chains and a screw to keep the lid closed. It's not as critical as actual pressure cooker operation. Yeah, it's not as critical as actual pressure cooker operation because there will be no pressure. If pressure builds up, you made some big mistake like plugging up the cooling pipe. Yeah, if you thought the chain was funny, then come around and show the safety valve. It's like, yeah. As I said, it's all cheap and made up, but it works. No, it doesn't. Crap. It could work. So, yeah. Then, as I said, you put the mesh in, close the lid, turn on the gas stove. It's a gas stove because, yeah, with no other kind of stove, you can regulate the power as fast. Maybe with an induction heater, but that doesn't work with a GDR pressure cooker. Yeah, then you started heating. At some point, evaporation will start. It will go up here past the thermometer so that we can see the gas temperature. And then the gas will run in here in the cooler. And there it hopefully condensates so that we don't blow up the operation. Yeah, we put some great effort into our non-functional model. We even painted it to look chalked. There's another thermometer in here so that we see that the cooling system is as cold as it's supposed to be. And yeah, then if it would work, the alcohol would drop out here and run over the last temperature sensor so we can see how warm it is, because yeah, if it gets too warm, it will be vapor, and that's bad. And just for the fun of it, there's a additional temperature sensor on the connector board. That's this one here. Yeah, that's just to measure the room temperature. So yeah, now we come to a totally made-up graph of an operation. The red line is the gas temperature. That is always the most important one, because at the current gas temperature you can see what, or you can at least guess what chemical is currently running, evaporating. The big plateau you can see at the top, that is where the alcohol would be, assuming that for a long time there would be alcohol coming out of the mesh. That turns into a plateau. The orange temperature is the air temperature. The green line is what the output temperature would be. At the beginning it's something like the room temperature. Yeah, and then at the point where actual product starts dripping out, it cools down to the to the cooling water temperature, and then running through it. At some point, it will start separating because the cooling can't keep up, because we don't have a run-through cooler. We just have water in there, and that will start to heat up. The ticks at the end, where the temperature suddenly drops. Yeah, that could be caused by having too high temperature and too much alcohol running through the cooler. So then you'd turn down the heat a bit and it would start to drop, and then you turn it back up and it starts rising again. And at the end of a run through, when you open the lid again and the cold air comes there, all the temperatures drop again and you're done with it. So, as I said, it's all hypothetical. And the hypothetical results could be something like, yeah, stop. There was this methanol thing. So with a still of this size, you won't get any dangerous amounts of methanol. Yeah, we just to be safe, we drop the first 15 milliliters. We dispose of them properly by burning them on the ground. Yeah. Then what could the output look like? If you would do this, it would be a great idea to separate the output in 100 milliliter jars and measure each separately so that you can follow what happens. And it could be like the first jar would be maybe 58%, maybe the 9th jar would be 35%, because the higher the temperature gets, the more water evaporates, and so the alcohol rate is lower. Yeah, of those 6 glasses, maybe the first 6 would be usable, because the after run that has the stuff that evaporates at the higher temperatures would taste bad. Yeah, and if you wanted higher percentages, you could just still it again, and then you'd maybe get up to 78%. Yeah, as Franziska already said, we measure the output of the still. We would measure it with the hydrometer. Yeah, and then 78% is nothing you ever drink. You only taste alcohol and nothing of the fruit. So if you had a still output with 78%, you would dilute it with water to get it to 40. Yeah. Now, this is illegal, so we don't do it. But there's another method which is kind of interesting. It basically uses the same principle. Just it's not the separate boiling points, but the separate freezing points. And then to use this, you put alcohol, maybe red wine, into a plastic bottle, put it into your freezer, let it freeze through, and then you turn it around, and the first stuff that will drop out is alcohol. Kind of an interesting picture is this here, because yeah, we have liquid dropping down, which is so cold that the condensation on the other vessel freezes. So we know the liquid is something with a freezing point well below the freezing point of water. If you measure this, you'll see that the output has something between 20 or 40% when starting with a red wine of 10%. So it really works, and I found it kind of interesting because except some crazy guy in Bavaria, I don't know of anybody actually using that, and that guy uses it to create the world's strongest beer with like 58%, and it's still legally beer because of German laws. Yeah, here we see that's the stuff that stayed in the bottle, and yeah, until after it unfroze, and that's the stuff that dripped out below. So yeah, if you put a light behind it, you see that the one side is much darker. So apparently the pigment is solvable in alcohol. It's just an interesting fact we saw too. And yeah, that's what we did. So in conclusion, it's totally possible to build a non-functional model of a still with hardware store parts. Running this, risk exists, but are manageable. Watch out for proper cooling. With such a cooler, it's just make sure that there's water in it before you start it. Yeah, methanol poisoning can be prevented by using clean mash, like mash you'd drink unstilled, and discarding the first 50 milliliter. And if you had something like this, and say you'd tried to still whiskey, you should look out for foaming, because if you try to run it too fast, maybe the mash would foam up and clog your still, and that'd be bad. So yeah, don't do that. In conclusion, it's great fun. theoretically. And yes, do not do this, it's illegal. Thank you.
What a fabulous practical introduction. So we have now 5 minutes for Q&A. So everybody who wants to ask a question, please go to the microphones and please stay in the room for this 5 minutes. Is there any? And keep in mind, this time everybody has to go out on this side. So, is there any question in the room? Microphone 1, please.
Yes, thank you for the talk. Thank you for the ideas. Do you know how the legal aspects are in Switzerland?
In Switzerland, you guys are actually quite well off because you're allowed to have small stills until the capacity of 5 liters. We have until the end of 2070s then 0.5 liters, which is basically useless. You can try it once, but for each run you get maybe a shot of usable liquor. In Switzerland you have 5 liters and then you get at least some, 200 milliliters of usable spirits, and this is actually fun to tinker with. This is something you and your fellows can, have a decent evening.
Microphone 5.
Yeah, so when I saw them electronics, that's usually not so safe to drink from, lead and everything. So do you have any tips for how to solder so it's safe for drinking?
I forgot to mention it. We used lead-free solder. That's a really great comment of you. And I looked it up, and the solder you can buy in a hardware store next to the copper tubes, that is lead-free. But check that to be sure. You don't want lead into your spirits.
Microphone 1.
Could you do the cooling per airflow instead of water?
I've seen online some people who did that with construction that looked kind of like a CPU cooler attached to something which had vaporous alcohol run through it. It'd be illegal to try, so I haven't, but this guy apparently has, and it worked for him. So but I don't know how you'd construct the copper block which you attach to the CPU cooler, so there's that.
I've seen silver etchings in really, really old manuscripts that were using just air to cool down, but that's technology from 500 years ago that says, use water.
Microphone 5.
You showed the glass part still, and you said it could not be purchased until after the 1st of January, right?
Yeah.
But if you just purchase the single parts because it's standard lab equipment, is this also illegal?
I mean, you don't purchase a still per se,
exactly.
do you?
Exactly. It's standard glass.
I don't think this is going to be a problem. But, there's laboratory equipment and they sell you a still made from glass for training distillation or so, and it costs some 250 euros, and they sell you the same exact parts this still is made of for cheaper. So you basically order 3 or 4 times different equipment parts from different vendors.
Yes.
I mean, this is ridiculous. Really, it is.
Thanks.
Okay, microphone 1.
Yeah, hi, thank you for your theoretical explanation. I have one question, but first I just wanted to mention that you can build all this without programming. You can buy a physical thing to measure the temperature, so if anybody's afraid because of that part. And yeah, then my question is there a reason why you don't use or just mentioned turbo yeast or stuff like that, where you can reach 20% in 2 days? Is it not that tasty or stuff?
Yeah, I think actually we just used the first one we got hands on, didn't we, for the first experiments. I mean, you could try it, but then you always it has negative parts, so maybe it's the taste, maybe it's something else. But I mean, I wouldn't claim that you achieve high quality taste with what we just showed.
I can answer one part for the Abfundingsbrennerei. You could use turbo yeast, but turbo yeast is something, I'm not really sure about the translation, that is called Hefe-Nährsalze, which is salts that you need to actually have an environment for this turbo yeast. And this Hefe-Nährsalze are unfortunately not allowed in Abfundingsbrennerei. So usually you don't use turbo yeast, and you don't actually need it for fruit spirits. It's okay if you want to make grain spirits, but you know, the higher the yeast ferments, the less, as I said, the less taste and scent remains in the distillate. So we want to have taste. So otherwise, we could just buy vodka in the store.
Okay, microphone 5, please.
Yeah, thanks again for your talk. Regarding the cooling, is it necessary to cool it with room temperature water, or why not chuck in some ice cubes or crushed ice to keep the temperature lower, or hinder the rising of the temperature in the cooling vessel?
Well, let's say we had run this hypothetical operation in our minds multiple times. Maybe the first time we had tried it with ice cubes and then started exchanging the water. Maybe we had a few times thought about running it and using just tap water and exchanging the tap water multiple times. And then maybe in our minds one time we forgot to change the water and it still would have worked. So we made up all further operations just with a bucket of water and not changing it. So yeah, point is that's the easiest way and it works.
Thanks.
And I saw that there is some question from the internet.
Exactly. The internet wants to know if there is a limit or a legal limit to the freeze distillation, as they call it, the ice rising process.
I tried to look it up, but I didn't find anything about that. So maybe there's a thing that if you're, let's just stay with the beer guy from Bavaria. The customs actually have a page about producing beer at home. You can do that legally in Germany, and the first 100 liters are tax-free, so you can just do that. So yeah, then you have 100 liters of beer and you just start concentrating them, and once you're done with that, it gets complicated. So I guess that's the limit. And then that guy probably just taxes the further beer, and that's how he does it.
But then you don't have to register your freezer at the tax office, so maybe people won't be that eager to check.
Okay, then the last 2 questions. Microphone 1.
Okay, so my question is about the freezing method as well. What is about the methanol for the freezing method? Is there some way to get rid of this, or is it really unnecessary?
Well, as I said, the stuff in the pictures was red wine from Aldi, because you don't experiment with expensive stuff. And if I drink a whole bottle of Aldi red wine, nothing bad happens to me. So I guess if I take any part of a bottle of red wine from Aldi, nothing bad will happen too. So there's that.
So there shouldn't be methanol in the original stuff?
There probably will be, but less enough so that it's not a problem.
Okay.
The thing about the methanol is, if I'm allowed to add, is methanol comes from the pectins. Pectins are basically the building substance of the cells. But if you have juice or wine, we already pressed it down, and the pectins stay in the stuff we throw away. And so in the juice and in the wine that we cool down, so there is very little methanol in it. This is different if we make a mash and have all this cell residue still in the mash, then we have the methanol in this mash. And so we have it in the distillate.
Okay, the last question, microphone 1, please.
Hi. Thanks for a great talk. My questions are around the head, heart, and tail. The hacked distilling method, I gathered you pretty much did it in what you took first, second, third, fourth out of it, and you divided it up like that. But in the craft distillery, how do you do it? Do you use it by controlling the temperature of the evaporation and the distilling liquid, or do you also do it by breaking it into segments? What's the technique you use to separate?
There's actually many roads that lead to Rome. So you could basically use this fractioning method that was described here, that you just take always 1 liter and 1 liter and 1 liter, and then you check it by smelling and tasting if it's okay or if it's not. And then the other way is, for example, temperature control. So if you buy a modern still from an experienced coppersmith, this is made with any types of sensors, and that are telling you the temperatures, the flow, the alcohol content. So you can basically program your still to automatically cut the foreshots and the aftershots. So this is another way. Then you could, for example, distill once or twice, and with the first distillation just take every alcohol that's coming out and then collect this first run and then redistill it and then make your cuts for the heads and the tails. And you can make it otherwise. You can cut the head and tails in the first run and then just basically concentrate in the redistillation. So there's many roads that lead to Rome, and you're just going to find out your way that suits you best. But if you start, I would take the fracturing method, yes.
Your still? What do you run your still on?
Sorry?
What technique do you use for your business, your still?
You mean my still at home, the craft still that I get on the... Yeah, this is experience. So we know the first 1.5 liters is foreshots, so we collect those and then we redistill them again. But at some day my great-grandfather most probably has found out the way, and he taught him his son, and now I know it that I don't need to get rid of 1.5 liters of foreshots. You're welcome.
Yeah, then at the end of this double feature, I expect a very big warm applause for Franziska, Andreas und Stefan.